This video is on slope and rate of change. These are real-world context problems. Rate will always have two different units and can be expressed using the word per. Basically what this is our change in y divided by our change in x is the y units per x units, because it's going to be the change in y divided by the change in x. Slope is also used for unit rate. Something from middle school, we learned about unit rates. This is the per one x value. So if you are buying a bunch of bananas and you know how much the pack of bananas or the batch of bananas are, you can determine what each individual banana costs. That is your unit rate. You have all of it together, but if you simplify it all the way down to have 1 in the denominator, you can determine what the unit rate is. So when we read our real-world context problems, we have to understand what our two different units are and which one are our y units and which one are our x units. So it would be y units per x units. Our first example says, when Clara was 3, she was 32 inches tall. Now she is 8, she is 45 inches tall. What is the rate of change in her height each year? So our units here are, she's 3 and 8. That's her years. That's how old she is. And then the second unit is the inches tall. So it's the actual height. So if we read this, we have height each year. That can be rewritten as height per year. How many inches per year does she grow? So this would be our y per x. So if we write that out, our coordinates would be, our x coordinate would be our year, and our y coordinate would be our height. Because we still need to find the coordinates so we can do our change in y divided by our change in x. So with this information, we can write out two different coordinates because we have two different pieces of information. The year, how old she was 3, and her height was 32 inches tall. That's one coordinate. And again, another year and another height. When she was 8, she is 45 inches tall. So our next coordinate is 8, 45. Because it's 3 years, 32 inches, 8 years, 45 inches. So a rate of change in her height each year. So we want to find our change in y and our change in x. Change in y equals, so I'm going to use from 32 to 45. From 32 to 45, it is a positive 13 inches. Then we're going to do our change in x, which is our years. So I started at 32 to 45, so I have to go from 3 to 8. So I'm doing my first coordinate to my second coordinate. So from 3 to 8 is a positive 5 years. So together, our change in y divided by change in x is positive 13 inches divided by positive 5 years. Notice I am still using my units. So going back to unit rate, we know that in 5 years she grew 13 inches. But on average, what was her increase in height per 1 year, which is what the unit rate is. So if we were to simplify this, and in real world context, we can use decimal values. If we were to simplify 13 divided by 5, we would get 2.6 inches per year. So understanding our units are important as well. 2.6 inches per year. So what this means is Clara grows 13 inches in 5 years, but for the unit rate, it would be 2.6 inches a single year. So every year she is growing about 2.6 inches. And that's what it means by unit rate. The slope would be 13 divided by 5 because that is a simplified fraction, but in context of the problem, it would be Clara grows 2.6 inches every year. If we come down to example 2, it says Todd had 5 gallons of gas in his motorbike. After driving 100 miles, he had 3 gallons left. What is the rate of change of miles per gallon? Well, we are already told the miles per gallon, so that is helpful. We have, as a reminder, it's y per x. So we have y as our miles and gallon as our x. So coordinate-wise, it'd be gallon, comma, y would be miles. So using this information, we can write coordinates. Todd had 5 gallons of gas in his motorbike. Well, he has 5 gallons of gas, but he has not driven. So the amount of gallons he has is 5. How many miles has he driven? He has not driven anything yet, so it would be 0 miles he has driven. And it says he drove 100 miles, and he had 3 gallons left. So now he has 3 gallons of gas, but he has driven 100 miles. So now we can find our rate of change of miles per gallon. And we again want to understand what the unit rate is, because we know that in this many miles, 100 miles, he has used so much gas. But how much gas does he use per just 1 mile? That's really what we're thinking about, okay? Or how many miles can he go in just 1 gallon? So as we do this, our change in y is from 0 to 100. So that is plus 100 miles. Our change in x will be from 5 to 3, which is minus 2, and that's gallons. So now we have our change in y and our change in x, so we can divide this. Change in y is plus 100 miles divided by our change in x is negative 2 gallons, which simplifies to negative 50 miles per gallon. So to understand this in context, every gallon of gas he uses, he will have been driving 50 miles. So we can say to make this a little bit more sense, every 50 miles, Todd uses a gallon of gas. So using is where the negative comes in. So every 50 miles, that's the 50, He's using, so that's minus because he's taken away the amount of gallons he has. Example 3. In 1998, Linda purchased a house for $144,000. In 2009, the house was worth $245,000. Find the average annual rate of change in dollars per year in the value of the house. So annual, so that's every year. So we want the unit rate of 1 year. So we have the dollars per year. So we have our Y per X. So if we come over here, we have our X is going to be our year. That's the year that we actually have, like 1998. And then our Y is going to be the dollars. That's the amount of the house. So that's our X and our Y. So our 2 coordinates. It says in 1998, that's a year, purchased the house for $144,000. So the year is 1998. And the dollars is $144,000. And then we have another year. In 2009, the house was worth $245,000. So our year is 2009. And the dollars is $245,000. We have our 2 coordinates, so we can do our change in Y over change in X. Change in Y will be from $144,000 to $245,000, which will be $101,000. So plus $101,000. I will not use the comma only because in my math, because you can't put commas really in the calculator to actually simplify them. The change in X will be the amount of years that have passed. So from 1998 until 2009, that will be, so from 98 to 2008 will be 10 years. And then I have another year, so it's 11 years. So plus 11 years. So if I want to do the slope, change in Y over change in X, this is $101,000. That's my dollar symbol. So that's my unit. And then 11 years. So if I were to simplify this, I would use a calculator and I would get money is $9,181.82. So that's dollars per year. That is our slope. So what this also means in context, the annual rate of change is that every year the house increases $9,181.82 in value. So again, this is the unit rate because it's per 1 year. We know that in 11 years, it increased by $101,000. But I wanted to know how much does it increase every single year to get to that $101,000. This last example says Marion's computer battery was fully charged at 8 a.m. By 10:30 a.m., her battery was at 65%. On average, by what percent did the battery decrease per hour? So we again have battery decrease. Percent did the battery decrease per hour. So we have our Y per X. So for our coordinate, we would have the X is our hour, which is going to be the time, comma. Our Y is going to be the percent So what is the percentage at? So I'm just going to put the percent symbol. So this is an X and a Y. So our coordinates. It says Marion's computer was fully charged at 8 a.m. So the time was 8 a.m. And the charge was 100%. And at 10:30 a.m., her battery was at 65%. So the hour is 10:30. So we have to remember time is not out of 100 minutes. It is out of 60 minutes. So be careful about the timing. And then it's at 65%. Now that we have our coordinates, our change, we can do our slope. Change in y was from 100 to 65. So that is a decrease. So that's negative 35%. Our change in x is from 8 a.m. to 10:30 a.m., which is 2.5 hours. So we would actually write this as plus 2.5 hours. Now our change in y over change in x would be negative 35% divided by 2.5 hours. That's how we would write our slope. But then we want to simplify that to have per 1 single hour to have our unit rate. So dividing this, 2.5 is already a fraction, so please understand we're not just dividing by 2, we're dividing by 2.5. So it is a little tricky when you're dividing by decimals. So when you're doing this, negative divided by positive is a negative. 35 divided by 2.5 is 14. So negative 14% per hour. Always use your units. This is our average of percent that the battery decreases every hour. So we could say that every hour, battery loses, because that's what the negative is, 14%. So again, always understanding that, yes, this is your slope, and you can simplify this as a different fraction as well, but putting it back as a unit rate, especially in context of the problem, is more beneficial than just having the fraction, because that way you know what it is per every single one, so that way you can utilize the numbers to do other questions for that same problem. Because now I could determine how long, because now that I know it's 14% every hour, I could determine how long before the entire computer dies without charging it, because I know how many per hour it decreases by.